Hi everyone. So the goal of this video is to understand forces. Specifically, I want you guys to understand this relationship between force and net force, mass and acceleration, and to be able to execute some calculations, whether they're simple calculations or maybe a little bit more advanced calculations. All right, so a quick preview. We're going to talk about what is force and how there's an equation for force. I'll talk about what is mass because we haven't quite talked about that. We'll have a worked example. That's something that you put in your guided notes. What is net force? What does it mean to have a balanced or unbalanced force? And then we'll talk about some free body diagrams, and then we'll do a few more worked examples. All right, so force is equal to mass times acceleration. That's a crucial equation that I want everyone to understand, and you're going to have to be able to use that equation for the practice problems. So it's part of Isaac Newton's second law that says force is equal to mass times acceleration. And sometimes that's just written as F equals ma. And that's what you'll see on the rubrics. That's what you'll see on a lot of the handouts. And that's just a shorthand way of saying force is equal to mass times acceleration. The SI units for force are newtons, named after Isaac Newton. One of the great things about science is you can name things after yourself if you want to. And so Isaac Newton was a famous scientist, and he was actually a great thinker of the 1600s, and he came up with these three laws of motion, and they're crucial. And the second one has this equation that says force is mass times acceleration. And so when we think about that, think about a force as like a push or a pull. You have some mass of an object, it could be a car, and then that car could accelerate. So if there's some force that's being applied to the object, then it's going to accelerate. Some common phrases you'll hear are push, pull, apply or applied, exert, or acting on. So those are all phrases that you'll hear, all related to this idea of a force on an object. So one thing we haven't talked about quite yet is mass, but I think some people might have an intuitive understanding of mass, but there's just a few things we need to clarify. So mass, the definition is how much matter is in an object. So it's kind of a vague definition. But it's kind of like how much stuff is there. And so the more stuff there is, it's like the heavier it feels. In the United States, we often use pounds, but in other countries and in physics, we're going to use kilograms, or sometimes you'll just see the abbreviation for kilograms is kg. You might have seen a mass set like this. So the bigger mass of the group is 1 kilogram. A person like me might weigh 80 kilograms. So just to kind of put that into perspective, how big is a kilogram? And 1 kilogram is 2.2 pounds. All right, so let's do a little example here. So let's say we have a 10 kilogram disc and it's pushed on the ice. The puck accelerates at 3 meters per second squared. What force was applied to the puck? All right, so this one we have, and we already have a picture right here. That's kind of like our model. We have some kind of puck that's going to be pushed. Let's say it's being pushed in the right direction. Um, our acceleration is positive, so that means that our force should probably be positive. And so we know that the mass, so we'll say m, it's not very good m, but you get the idea, is 10. I can see my acceleration is 3. And so the question is, what is my force? And so you might be able to see from the equation that all we're going to do here is we're just going to multiply the m times the a to get the f. So we're just going to use this equation right here. So on your papers, I'm going to want you actually to write out the equation. Every time you do a problem in my class, I want you to write out what equation did you decide to use. And then from there, I want you to show me what numbers you plugged into the equation. So I should have a 10 right here for the mass, and then I should have a 3 over here for the acceleration. So that means my force is going to be 3 times 10. That's going to be 30. And again, remember to include your units every time you do a problem. So this would be 30 N. The N stands for newtons, which is how we measure force. Okay, let's do another one. This one's slightly different because here we're actually given the mass and we're given a force, and now we have to find acceleration. So I want everyone to be familiar with this. When you're trying to find the number that is on the other side of the equation, what math do you do? So let's say we have mass. Again, same setup as last time. We write out our variables. We have a mass of 10. We don't know our acceleration. So I'll put acceleration as a question mark. And that's what we're actually trying to find. The question is saying that that's what we're supposed to find. And then F is equal to 25. Okay. So here, again, we're going to use that same equation of F equals, try to make that a little bit clearer, F equals MA. One day I'll get on the level of like Khan Academy. You know, oh, that's not right. Okay, that's a scribble. Let's not count that. What we want is 25 as a force is equal to 10 times A. All right, so here, if I have a 10 times A, and I'm trying to figure out what A is, well, if I have 10 times A, to get rid of this 10 and to get A by itself, I want to divide both sides by 10. If I have a 10 being multiplied by my variable, I want to get rid of that 10 by doing the opposite of multiplication. The opposite of multiplication is division. So these things would cancel out. And I'll get A is equal to 25 divided by 10. So you get A is 2.5 meters per second squared. I won't try to scribble all that on the wall. I think you guys understand what I'm doing here. Okay. All right, so let's go over this other key concept, which is net force. So net force is the total force acting on an object. We could have 2 people or 3 people or just lots of different forces acting on the same object. And if that's the case, well, what we want to do to find the total force is just add up all the forces, keeping in mind that some forces might be negative and some forces might be positive, depending on which direction they're going. Right? Force is a vector, which means it has a direction. So you have to be clear about which way you're moving, left or right. And so this equation is not to be confusing, but let's just break this down. Basically, this is a fancy symbol for sum, like to add up everything. So the sum of all the forces, well, that's the same thing as saying your net force, right? Your net force is how much do you have left over, right? A common way that we use the word net is in economics when we talk about money. Like what is your net gain or what is your net growth? That usually means after you've taken in some money, but after you've paid all your bills, what do you have left? And that's what we might call your net gain. All right, same thing in force. After you consider all the positive forces and all the negative forces, what do you have left? And to do that, you just have to add up all your forces. You could have 2 forces, you could have 3 forces, you could have lots of different forces on one object. You just add them all up and you'll get the net force. And so kind of related to that, we might hear about balanced forces. So balanced forces means that there is no net force. The forces are balanced. You might have 50 newtons from one side and 50 newtons from the other side, and those two things would balance each other out. So there's no net force on the object. Or in this case, in the game of tug of war, we have 300 newtons to the left, but 300 newtons to the right. And these two teams might be struggling for a long time because they're not really going to go anywhere. The net force is 0. And there's going to be no acceleration if the net force is 0. That's a balanced force. An unbalanced force is when there is some net force. The net force is not 0. So the object would actually be accelerating. And it could be slowing down, or speeding up. But if there's some net force, then that means there is some acceleration. There's going to be some change in the velocity. So the object must be changing its motion somehow. So in this case, this person is getting beat pretty bad. That's not fair. But 300 to the left and then 100 to the right. And so we have a net force here that's going to the left. So what we might do sometimes is we might draw a free body diagram. And it's just a drawing used to show all the forces acting on an object. And here are some very simple directions. We can draw a square to represent the object being pushed. And we do this no matter what the object is. Sometimes just drawing a square just makes it very easy for us to visualize what the object is and what forces are acting on it. And then you want to draw vectors for all the forces acting on the object. And then you want to find the net force by calculating the sum of all the forces. Once you have drawn all your forces, you can kind of see which one's going left, which one's going right, and then you can add them all up to find what is your net force. So let's try to do a quick example here, kind of related to the picture that we saw before. But in this case, we had one team was actually losing. So this is a picture of the teams being tied. But then there was one picture where the teams were not tied. And there was one team certainly winning. So team A was pulling with negative 300 newtons. That means 300 newtons to the left. Team B pulls with a force of 100 newtons. What is the net force? So this one is pretty straightforward. We have two forces. We could say F1. F1 is, let's say, negative 300 newtons. We kind of already have a model in the top of our screen there, so we might not have to draw our own model. Actually, you know what? Let's just draw it because I want you guys to get used to it. So let's imagine that we have, some kind of rope here. I don't know. Let's try to give it some size. And then we have 300 this way, and then we have only 100 this way. I'm going to try to draw the 100 a lot smaller than the 300. So we have 100 this way, and we have 300 this way. So that could just be our simple model of what's going on with the forces. All right, and so just to kind of continue where I was with the variables here. So F2 is equal to 100 newtons. If you ever want to speed up my videos, you can change that on YouTube. There's a setting where you can control how fast the video goes if my writing is too slow for you. All right, but my net force, and actually let me be clear about this, is F net. Sorry if my handwriting isn't great on this, but my net force would be the two forces added together. So it'd be negative 300 plus 100. All right, so that's the kind of thing I'm looking for. When you guys do these problems, make sure you give me a model, make sure you write your variables, and then show me what equation you're choosing when you try to solve the problem. All right, I'm sure you guys can see the math from there on. So the net force would be negative 200. All right, this one is a little bit different. So let's say I'm pushing on a table and the table is accelerating at 2 meters per second squared. Now, I might be pushing on the table. There might be some force against me. There might be some force of friction as I'm pushing the table. There might be some friction between the table and the floor, and it might not be such a smooth movement, but I am making the table accelerate. So let's maybe draw a model of this really quickly. So we have, we just draw the table as a box. I know that I'm pushing it this way. There might be some friction this way. Okay, but what I know is that the mass is 74. See if I can make a 7 here. 74. And then the acceleration is 2. Well, I don't need to know all the forces in this case. What I do know is that the net force, the overall force, is just going to be the mass times the acceleration. So what I need to do here is I just need to multiply. I just multiply my two numbers. So the net force, or the total force, is just going to be 74 times 2. All right, and I'll leave it there. I think you guys can kind of see what I did there. I just said force equals mass times acceleration. All right, so there's just a few worked examples there, and hopefully you see some of the variety there. And based on the numbers you're given, you kind of have to figure out what equation is appropriate. Should I be using F equals ma, or should I be using the net force equation of F1 plus F2 plus F3? All right, so you have a few practice problems to try, so good luck with that.